All right, guys, so the next section is going to be 7 through 12. So looking at the odd problems, I'll probably just do 7, and I might even pick 11 to explain pretty quickly. But this is a key part of the reading and the homework from last night. So, we have pi over 5 and then 7 pi over 5, right? And if you kind of got, the idea is we have this, a unit circle, um, but we have, all right, this is our initial position. This is 90 degrees right here, right? So from an angle from standard position to there, that's 90 degrees, and 90 degrees is there. So plus another 90 degrees. This over here is 180 degrees. This here is 270 degrees, and then back to the front. So all the way around one is obviously 360 degrees. But when you think about it in terms of radians, right, because this question is in terms of radians, right, this is 0 radians, just like it's 0 degrees. Straight across is pi radians. All the way around once, right back to the same spot, could also be 2 pi radians, right? Different angle than 0, but they both end in the same spot or terminate in the same spot. So like what are these ones, right? Well, in between 0 and pi would be half of pi. So we say that's pi over 2. And then in between 1 and 2 pi would be like 1.5 pi. So that's 3 pi over 2. And that's kind of like the huge building block of everything we do everything off of. So if the question was, let me go back to the question here, pi over 5 and 7 pi over 5. Oh, I lost it. But here we have this again, right? So pi over 5, this is pi over 2. So that's like a half of a pi. So pi over 5 is like 1/5 of pi. So that's a much smaller fraction, 1/2. So pi over 5 is going to be somewhere in this area, but that's going to be in quadrant 1, right? The next one was 7 pi divided by 5, right? So again, 7/5, that's a fraction that's bigger than 1. And we know that 1 pi is over here, right? So it's just a question of is 7/5 going to be over here or is it going to be over here, right? So basically this is 1 pi, and then over here was 3/2 pi, or 1.5 pi, right? So is 7/5, like keep everything in terms of pi. This is 1, this is 1.5. Is 7/5 bigger than 1.5, which would be over here, or is it smaller than 1.5 over here, right? 7 divided by 5 is like 1.4, but it's not bigger than 1.5. So quadrant 3 would be the answer for that one because 7/5 as a fraction is smaller than 1.5 or 3/2, right? And then the second part with that, another question, I am going to do the other question, like something like 11, 3.5 and then 2.25, right? Now these, you notice that there's no pi, right? So 3.5 and 2.25. These don't have pi attached to them, so it's not like 3.5 pi. You can say, okay, well, 1 pi, 2 pi, 3 pi, 3.5 right there. It's not, because these, again, they don't have pi. This is just the number 3.5 radians, right? 3.5 pi would mean 3.5 times pi, which is 3.14, which would create a bigger number. So you have to kind of guesstimate, all right, where's 3.5 radians going to be? And again, kind of use the same thing, right? We know that over here is pi, which is about 3.14, right? This is 2 pi if you went all the way back around. So 3.14 doubled is like 6.28. So 3.14, 6.28. We're just thinking in terms of decimals, so we don't have to deal with pi. You know, if you add like pi over 2, which is right here, is, half of pi. So that's like, 1.57. And then if you take 3.14 and you add another 1.57, you'll end up with like 4 point something. But either way, 3.5 is definitely between 3.14 and that 4 point something. So 3.5 is going to fall somewhere in this quadrant. It'll actually be pretty close to pi since it's only 0.14 and 0.5. They're not too far apart. So that's going to be quadrant 3. 2.25, again, it has to be somewhere in quadrant 2 because 3.14 is kind of that quadrantal spot here, and 1.57 is the quadrantal spot here. So 2.5 is somewhere in between 1.57 and 3.14. So that answer is quadrant 2. So hopefully you have enough info to do the rest of that section.